Hey, I am back and I'm going to be doing page 228 of the notes. And I think this might actually be a quick one, but we'll find out. So we want to find the exact value of the direction cosines of each of the given vectors. If you recall, the direction cosines are just the components of the unit vector. So what I'm really going to do is find a unit vector. With this vector, if I have to find the unit vector, I'm not going to work with 3, 6, 9. I'm going to rewrite this thing as 3 times 1, 2, 3, because the vectors 3, 6, 9 and 1, 2, 3 are just scalar multiples of each other, which means they have the same unit vector. So I'm actually going to find the magnitude of 1, 2, 3. So I'm going to say the magnitude of 1, 2, 3. So always work with a scaled down vector if you can. Not necessarily a unit vector, because unit vectors, the magnitude can be gross, and then you have a weird radical, you have to deal with that. But like 3, 6, 9 is, if they have a common factor, take that out right away, because usually with vectors, what you really want is like the direction that they point in. And, you don't want to have to square bigger numbers, basically, is, the lazy reason. All right, so this will be square root of 1 squared, 2 squared, 3 squared. 9 plus 1 is 10 plus 4, so radical 14. All right, so we have that. And then what I want to do is I'm going to say that V over the magnitude of V. So it's kind of like I'm cheating here. So like the magnitude of V is actually 3 root 14, right? Because it's 3 times this other vector that I made. But I'm just using the other vector because I have the same unit vectors. So V over the magnitude of V is going to be 1 over root 14, 2 over root 14, and 3 over root 14. Because if I use the original one, I would have had 3 over 3 root 14, 6 over 3 root 14, and 9 over 3 root 14. They all would have canceled down. So like use that scaled down version. That's why it's called scalar multiplication, right? Like you just scale it. You don't change the direction. Unless it's a negative scalar, in which case you flip the direction, but we didn't do that here. Okay, and then I need to answer the question. Like I found a unit vector. I didn't really answer the question. So I'm going to say cosine of alpha is 1 over root 14. Cosine of beta is 2 over root 14. And cosine of gamma, holy cow, my gammas are not the best. Cosine of gamma is 3 over root 14. And those are the direction cosines. All right, let's try this one. Right away, I need to find the magnitude of W. The square root of, well, so it's 25 plus 25, right? Because 3, 4, 5, right? I'm always intrigued by those. So, like, what is it? There's 3, 4. There's like some Pythagorean, like, I don't know, like ordered triples. They're not really like Pythagorean, but it's like if you have like 3, 4, 12, I think. 3, 4, 12. Let me try that in a second. Hold on. All right, so I'm going to jump right to it. Cosine of alpha is negative 5 over. So this is like root 50, which is 5 root 2. So I probably would want to simplify this. 1 over root 2. Except they don't all simplify. So like I really don't. In fact, I don't like, whoa. Get back. Okay, so I don't like any of what I just did. So I'm gonna get confused. Get out. Get out. Oh, all I can do is redo? Is that what you're telling me? What if I erase? Here we go. Okay, remember when I said I thought this would be a quick one? I think we all knew that wasn't true, even when I said it. So here we go. Cosine alpha negative 5 over root 50. Cosine of beta is 4 over root 50. Cosine of gamma, that's the best gamma that I've drawn so far, is negative 3 over root 50, and then we were done with that. Okay, so we got our direction cosine. So what I was saying was, I think there's some vectors or some ordered triples or whatever. So like, say we had like the vector r, this might not work. 3, 4. So I was going to do, okay, I was going to do 3, 4, 12. And then the magnitude of that is going to be the square root of 3 squared plus 4 squared, which is 5 squared, and then plus 12 squared. But like 5, 12, 13 is a triple. So this is 13. So I don't know. Do they have a name? Probably something. Everything has a name if you look hard enough. I just think that's neat, right? So like, see if you can think of any more that do that are like non-trivial, right? Like, don't just multiply by 2. Get 6, 8, 24. Like, we know that's going to work. Are there any others like that? I mean, probably. I'm not really sure. Off the top of my head, that one like pops up immediately because those are 2 triples that I'm very familiar with. Assuming I got it right. Who even knows? All right. Given a sphere, and we're going to find parametric equations of the intersection of the sphere and the plane. So this question says something weird, but all it's saying is find the trace. So if I'm finding the trace, what I usually do, so I'm going to start off just substitute, right? So if I substitute, if z equals 5, I just get x minus 4 squared plus quantity y plus 2 squared equals 25. Because 5 minus 5, when I sub 5 for z, it goes away. This is a circle with a radius of 2 that's centered at 4, negative 2. I have to write parametric equations for this. So x equals, y equals, z equals 5. That was given. So z equals 5. All right, so it's going to be 4, negative 2 is the center of the circle, and then the radius is 5. So I'll say plus 5 cosine of t and plus 5 sine of t. And that's not bad. Never be afraid of these, right? Like, you know what you're doing. Just dive in, do it, move on. All right, so make your substitution. It's still z, so y plus 2. Okay, so when I substitute 2 in for z, I get negative 3. Square it, that's 9. So I'm going to do 25 minus 9 is 16. And parametrics for this. So x will equal, y will equal, and then z will equal. So z is 2. All right, so centered at 4, 2, and radius of 4. So plus 4 cosine of t and plus 4 sine of t. All right, I think we got that. And then there's just more of them. Also, I really want to like do these on GeoGebra, if you'll bear with me. If you won't bear with me, when I'm done with these, just stop the video and go about your life. All right, if I plug in 7 for x, I get 7 minus 4 is 3 squared, I get 9. Subtract it, so I get 16 on the other side. So I'm going to say that I get, y plus 2 squared plus the quantity z minus 5 squared equals, I kind of forget everything that I said. I think it was 16. Yeah, definitely. Let me just check and see if that's right. I believe that is correct. Also, I just remembered I have the notes up on another computer that I could be looking at instead of like zooming like crazy. These notes should come with a warning, like if you easily get seasick. I mean, how do you even know, right? But if you do, these are probably bad for you. Y equals z equals negative 2, positive 5, radius is 4. 4, what are you doing? Okay, x was equal to 7. It's y and z this time. Plus 4 cosine of t plus 4 sine of t. Okay. And then finally, when y equals 0, so if y equals 0, I get, sub that in, you get 0 plus 2 is 2, squared is 4, subtract it, so you get 21, so that's kind of gross. You get x minus 4 squared plus, we did the whole thing for y, so that's gone, z minus 5 squared equals 21. So it just has like a bad radius. It's not really bad. Don't be so judgy about your radii, but still not ideal. Okay, so z equals, what am I doing here? Yeah, 4 and 5. and then plus radical 21 cosine of t, and plus radical 21 sine of t. Okay, so if you're just here for the notes, you are done with the notes. What I'm going to do is I'm going to take these and I'm going to go into GeoGebra and I'm going to graph the sphere and I'm going to graph these and just like see if I got it right, because that's like one of the things you should be doing. Like you don't have to wonder that much if you're kind of like learning how to use GeoGebra simultaneously. And it's always useful to know how to do different things on different software packages, different whatever. Anyway, develop that. Like become the sort of person who's interested in these kinds of things. So I need a new file, so I can probably just go here and go new. I do not want to save that. I don't save anything, which is probably terrible. All right, I'm going to graph the sphere, which is x minus 4 squared. So it's like a little, when you're checking your answer, I mean, I'm sure everyone feels this. I always get a little nervous, like, oh no, I'm about to show that I don't know what I'm doing. Equals 25. Although I will say, at some point in your life, you do things enough that you have the confidence that even when you're getting them wrong, you're just like, I know what I'm doing anyway. All right, let's go with curve. So the first one, 4 plus 5 cosine of t, comma, negative 2 plus 5 sine of t, comma, 5, comma, oh yeah, comma, what am I doing? T from 0 to 2 pi. Okay, let's see. Let me tilt this thing here. Why is it 0 to 2 pi? Why is 0 to 2 pi not going all the way around this thing? Oh, it is going all the way around. Let me zoom out. Oh, I got fooled. I wasn't seeing enough of it. So the whole thing was just getting like sheared off. It does this weird thing where it'll show you like surfaces beyond the box, but it won't show you curves beyond the box, which seems reasonable. But occasionally it will confuse you, as it did there. All right, let's see. Should I duplicate and just like modify? I think so. I'm gonna click here, duplicate 4 plus 4 cosine, and then positive. You're really positive too? You're not really positive. This should be negative 2. Okay, so negative 2. I'm gonna go back in the notes and fix that. But if you're still watching, fix that. Plus 4, and then z will be 2. You can see there we put like another belt around this thing, and then I'm going to type this one in, curve 7 comma negative 2 plus 4 cosine of t comma 5 plus 4 sine of t. It's almost like this is the fact that I made a mistake there is like a test to see who actually watches till the end, which like is not really a test, but it kind of is, you know. And then curve, so 4 plus square root. So if I was going to use the square root of 21 like over and over and over again, what I would do is I would just like type it in and then use it. So I'll show you what I'm talking about. So I would do like r equals square root of 21, right? And so now what I can do is curve. It'll be 4 plus r times cosine of t, comma 0, comma 5 plus r times sine of t. And I need t to go from 0 to 2 pi. And there you go. So it's kind of fun to put a lot of like belts around these things. I don't know. I enjoy it. I really like taking a surface and doing like as many traces as I can, so you get like a wireframe thing. I think I just like wireframe things. Okay, so I'm going to stop this. And I'm going to go back to the iPad. And I'm going to share the screen again. And I'm doing this all literally so I can put a negative. Let me use another color to highlight my shamefulness. Negative. There we go. All right. I think we're done with this part. I'll obviously be back in more videos to do more with you. Hope you're finding these helpful.